bromide will be used. Right? So combination of two chemicals will be usually used in vapor absorption refrigeration. Okay. So here at point number 1, we have low pressure, low temperature, liquid ammonia. Okay. So ammonia is a refrigerant here, similar to the previous case. Now at low pressure, low temperature, liquid ammonia will enter into the evaporator. What do you mean by evaporator? The space where actually cooling is required. That is your refrigerator. You are not interested, go for some audition. If you are going to discuss others, what is there to discuss? Tell me what is there to stand up and discuss with us. What is there to discuss? Okay, so low pressure, low temperature liquid ammonia, it will enter into the evaporator. Evaporator is your refrigerator where cooling is actually necessary. So this liquid ammonia, once it enters into the evaporator, there will be copper pipelines. It will be passing through it. Okay, you might see a white color board. I mean, a cardboard like structure inside your refrigerator. Behind that, there will be copper coils. In that coils, this ammonia liquid will be flowing. In the process, it will absorb the heat from the refrigerator. That is evaporator. So when it absorbs the heat, what happens? The liquid will become. What happens? Liquid ammonia is entering here. It is absorbing the heat. Okay. So once it is absorbing the heat, it will become vapor. Correct? I have given you the example of water. When you start supplying heat, initially it will boil, then it will become vapor. Similarly here, the liquid enters, it absorbs all the heat and it becomes vapor. So this is point number 2. Okay. So at point number 2, we have low pressure, low temperature. Okay, it's not liquid, it will be vapor ammonia. Right? Vapor ammonia. So here actually heat is absorbed. Okay, so heat will be absorbed at this point. Is it clear? This is process 1 to 2. Right? So next, after that, this ammonia will enter into an absorber. Absorber is a tank which will consist of water, the second component what we are using. Okay, so we call it as weak ammonia solution. Right? So when this vapor enters into the absorber, the solution becomes strong. Concentration of ammonia will increase, the solution becomes strong. Okay, is it clear? So 2 to 3 is the process of absorption. Once again, I'll repeat. At point 2, you have vapor ammonia. It will be sent to the absorber. Absorber is just a metal tank which consists of weak ammonia solution. Okay, good quantity of water, small quantity of ammonia, weak concentration. Right? So when you start supplying ammonia, what happens? It will absorb. Water can easily absorb ammonia. That is why we are using it as an absorber. Okay. So when you supply additional ammonia, it becomes a strong ammonia solution. Is it correct? Any doubts in 2 to 3 process? Then, okay. So 3 to 4 is a process where, so this is a pump. This is an engineering symbol which is used for a pump. Right? So what is the function of pump at your home? It's not motor. We call it as motor usually in local language. It's not motor. It's a water pump. What does it do? It pumps water from lower head to higher head. Correct? It does some work on it. It will vary the pressure. Because of pressure difference, water will be pumped. So here also we have low pressure ammonia. We need some pumping mechanism so that it can flow through the circuit. Without energy, it cannot flow. Correct? So this pump will take the solution from the tank and it will provide it to the next circuit called as the generator. Okay, so generator is the see this ammonia will be circulating between generator and absorber. You can see it's a closed loop. Right? Just try to absorb. See, we have a generator tank here, generator tank, and an absorber tank. Okay, it is a closed loop. Correct? ammonia solution keeps on moving inside this circuit. That is what you can observe there, correct? So in the second line, it is coming downwards. Yes or no? In the first line, it is going upward. So what happens? Whatever pump is there here, so we have a heat exchanger and then pump over here. Okay, so pump will take this liquid ammonia, rich solution of liquid ammonia through a heat exchanger. It will supply to the generator. What happens this heat exchanger? Okay, here whatever the back coming liquid is there, it will be very hot. Okay, from the generator to the absorber, every cycle some amount of ammonia solution will come back. That will be very hot. So that heat will be taken up by this cold ammonia solution so that it gets preheated. Are you following? Heat exchanger is a device which will not allow two substances to mix, but it will transfer the heat between those two, right? So whatever back coming ammonia solution is there, the excess heat will be taken by this cold ammonia solution. It gets preheated and it will be stored in the generator. Is this clear? Any doubts? 3 to 4 is movement to the generator. Next, in the generator, you can see there is something like this. It is called as the heating coil. Heating coil, you will supply electricity to this. Okay. So this solution, whatever is stored here, it will be constantly heated to 60 or 70 degrees centigrade. Right. So what happens when you start heating to 60 or 70 degrees centigrade? Water will not evaporate. Am I right? Correct or not? Beyond 100 degrees centigrade, if you heat, water will evaporate. Okay. If you heat it to 60 or 70 degrees, water will not evaporate. Only ammonia particles will evaporate and it will form a vapor. You can see the dotted structure here at the top, correct? Okay, that is all ammonia vapor particles. Is it clear? Water will never get evaporated at that temperature. So the remaining water will be sent back to the absorber. In the process of going back, whatever heat is there, it will give to the cold ammonia solution. Are you understanding? Okay. Now what do we have at this point 5? At point 5, we have high pressure, high temperature ammonia vapor, correct? In the pump, you are adding the pressure. Through the coil, you are adding the heat. So that high pressure, high temperature ammonia vapor will be there. That will pass through the condenser. What is the function of condenser? It will condense the vapor ammonia into liquid ammonia. Correct? So this liquid ammonia at this point 7, if you see, we have high pressure, low temperature liquid ammonia. The pressure will be released in an expansion valve and it will start recirculating. Any doubts in this? See, once again, I'll repeat. From the generator, we have a high pressure, high temperature ammonia vapor. Okay. In the point 6, that is in the condenser, now what is happening at point 6? The vapor ammonia is getting converted to liquid. Then the liquid ammonia enters into expansion valve. What do you mean by expansion? The pressure will be relieved so that at this final point we have low pressure, low temperature liquid ammonia. Again it will enter into the evaporator, take away the heat, again it will form vapor. It keeps on continuing. This is vapor absorption. The name vapor absorption is given because water absorbs the vapor ammonia in the absorber. That is the important key process in this entire cooling system. That is why the word vapor absorption refrigeration is given. Okay, so please go through any doubts you can ask me. Last topic of refrigeration application. Which goes to any doubts you can ask me. Have you understood? Yes, sir. Any doubts you can ask? Shall we move to the next topic? Next, we will move to applications of refrigeration.